I think I'm live. Hello. I'm gonna try to log into Twitch. Oh, I'm live. Okay. So, apparently the math police are after me, and I'm not sure what to do. Yes. So, today's agenda. We have a stupid induction proof. We have some ODE, and then some statistics, and then some Fourier analysis. Since I have a lecture tomorrow, I want to prepare a little bit. Also, I have a seminar tomorrow, so I should prepare some questions there. Man, why? Okay. There we go. Oh, biscuits. I forget to do this all the time. Why? Okay, well, I guess I, on YouTube I streamed the wrong, I started the wrong stream. No. I think I've made this mistake 3 times or 2 times. But yeah, today's stream will probably be like, I want to do 5 hours. I should do 5 hours. Tomorrow I'll have a lecture at 10, so I should be able to get good sleep and stuff. And 5 hours is also a decent amount of time to actually get some stuff done. Yeah. Biscuits, okay. Let me change the title. Let me just change everything. I'll make this private. And probably this is the most like cursed thumbnail I've ever done. But hello Nilenka, hello Isha. Welcome. So yes. I want to grab some water before we start. And yes, I haven't really checked if everything works, but I think everything is fine. So the induction proof that one of the first year students that I have for like one of my students, there was some annoying induction which I for some reason couldn't solve. How long is the stream gonna be? I said 5 hours, so if you missed that. So I'll try to do 5 hours at least. I think that'll be a good okay, so I think I think this was the induction, and it was for K4. I don't know, it was just difficult. Like for the induction step, let me see if I can do this. Haven't been here in a while. Welcome, Amelia. Amelia? Imali? I don't know how to pronounce your name, sorry. Like, you can bound it by this, I guess. Or, actually, I think this is the wrong way around. Okay, let's try. 4 to the power this is equal to 9 times 9, which is equal to 81. And then this is 4, 3, which is 16 times 4, 64. So it's actually the other way around. Yeah, seems reasonable. So I kind of embarrassed myself today. I kind of embarrassed myself. This was bigger. And this was like this. I mean, to be fair, I'm not really that mad since... I'm not... I guess mad is not the right word, rather frustrated. I'm not super frustrated since I think I know how to do it, but just, I don't know, for some reason couldn't do it in the spot. Oh, you're not even seeing what I'm doing. I think... what is the... Okay, so I said ODE 1 first. You know, I did miss ODE lecture, so I should probably do it first, eh? Yeah. Okay, let's... I'm just wondering where, if I have the file. Or like the digital copy of the book. I think it was on downloads. Yeah. I'm not really sure what the thing was. Let me just look at this here. Hopefully I didn't leak anything, or maybe I did actually just now. Frick. So sections 1.5. 2.2 to 2.3. I'll ask my friend for some lecture notes, to be fair. What am I studying? Yeah, so the agenda is doing the induction proof and then have some ODE, statistics and Fourier analysis. That's the plan. Alright, if someone can solve it whilst I'm getting water, thumbs up. Write it in chat. But yeah, I guess feel free to solve it. I'll try to do it after when I come back. All right. Alright. Induction proof, starting with those myself. Alright. Well, let's try to do it together. Let's see see what happens. Yep. Okay. So let's just jump to the induction step. I think this is correct. So it's 4. It's 81 and it's 64. Yeah. So I think I did it like this. And then this is less than K3 times 3. And somehow we need to get that this is less than equal to K plus 1, 3. And yeah, so this is not 100% obvious. I mean, sure, you can expand it. Or maybe that's stupid. Let's... I'm kind of stuck. Like, okay, wait, I'm doing it wrong as well. This is yeah, I'm doing the wrong side as well. Blah. So we need to find something that's smaller. Then this. Hello Shahid, welcome. This is not obvious for me at all. Okay, so we can expand this. Let's try that, I guess. Shade, you're saying ChatGPT? Well, I mean, I want to do this without ChatGPT. Because I'm kind of frustrated at this problem. So we have K3 plus K3. Is there some way we can argue that something is smaller? It just seems weird. I mean, look, we know K is strictly greater than 4, since our base case is 4. So we know that this is less than, or we can bound it by below, or however you say, by 3k square. And if we can bound this below by 3k plus 1, that would be fantastic. Which I guess works, since this is equal, I mean, we have K3, this is equal to K2 times K, and K2 is at least 16, so it has to be greater than 16. This is greater than 16. So if it's at least greater than 16, then something smaller is indeed 3. And then how do we get the 1? Well, adding a 1 will certainly not make a big difference, right? So this is clearly less than 1. Right, k squared is greater than 16. So 3k, it must be less than 3k, and plus 1. Let me just see here. I mean, we can do 3 plus 1 over k, right? This is less, and then we can expand it to get 3k plus 1. So I guess this would be the solution. It's really, I think it's very awkward. I don't think this is a nice way to do it, but who gives a shit? But this is certainly one way to do it. So then we get 3k plus 3k squared plus 3k plus 1. This is less than this, and this is equal to k plus 1 cube. Let's see how ChatGPT does it. GPT.com. I'll take your advice, Jade. Solve by induction that n3 less than all. So it's 4. Wait. Yeah. So this is less than 3. K or 3, yeah, K. Oh, n. 4n equal to 4, 5, 6. Studying G. I mean, I think I'm probably the worst person to ask for advice when it comes to G, or however you pronounce it, G-E-E. Since, wait, is this the public? I mean, I don't really know what it's about, what you do there. I mean, I think, yeah, you have physics, chemistry, math, and maybe some biology in zoology, I think. Or maybe that was the other one. But, so yeah, I don't feel comfortable I don't know, giving advice. Blah 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 blah. So we have this. He does it this step, and this is less than 3 times. Okay, there's some other. I am seeing after a long time loving the math streams. Hello Vanessa, thanks. G has 3 subject, math, chemistry, physics. Ah, okay. I think it was NEET or something that had zoology, no? Or maybe I'm just talking nonsense. Yeah. Oh, he's a parent. I don't want to spend too much time on this, but apparently. So the induction step says that 3 to the n is so it's supposed to do the so we prove this. Okay. We show that this is this, expand, this is less than 3n plus yeah, we have 3n. Yeah, 3n plus this. So we need to show that wait, what? Wait, what? Wait, I don't get this step. What? How do we get this? How does this imply this? That is not very clear to me. Very bad thumbnail. I think the thumbnail is let me look at it again. I really like it. It's one of the best thumbnails I've ever made. Yeah, what? How is that? How do we get that? I have no idea. Am I just dumb? Am I dumb? Does it? I mean, okay, let's think about this. If we, if this is true, 3 is greater than this. What does that show? Well, well, we can bound it by that. How does that show? How does that show the original equality? If we have this, like if we simply input it into the inequality there, we get 2 times r to the n, which isn't really what we want. I mean, I would agree if we show that this is less than or equal to 2 times r to the n, then I would be more satisfied. Huh. Am I missing something? So it would be enough for the leftover part was at most another. Let's see here. So if this is well, okay. I guess this is fine. So if we bound it by 3 to the n, we can bound it by 2 times 3 to the n. Okay. I don't know. I don't like that. I think my argument is better. Yeah. How long have I spent on this? 20 minutes. I'm satisfied with that. Hello, Genius Grind. Hello. Hopefully things are good. Yeah, let's move on to some ODE stuff. I've noticed that when I do ODE, like many people leave. I think it's I don't know. It's maybe not really that understandable. I mean, even for me. Just came to say my presentation went pretty good for once. I read a lot from the screen, but it's alright. Nice. Very happy to hear that. That's awesome. Now you deserve some relaxation. A break, maybe. Maybe some bridge, or whatever the game is called. Okie dokie. Let's move on. ODE. Let me still check how AI did. He bounded by this, so okay, never mind. I'm not gonna read that. Okay, so I remember where I was stuck, and I'm still frustrated, and I still don't really get it. ODE very smelly, so I've heard. It's not really. I don't know. I find it fairly difficult, and stuff like that. I'll skip the maximal solutions because I just don't. I don't know. It just isn't really. I just still don't really get it. So I'm just gonna skip it. And I'm fairly far behind when it comes to the actual material. I wanna see where. So I think it's week 3, or even. Okay, so let me duplicate. Let me check. Yeah, we began on chapter 2, 2.1. We did some cool stuff here. This is kind of understandable since we're just doing definitions and very like quick proofs or like direct proofs. So that isn't really that big of a deal. But then, so we had section, yeah, third is 2.1, and then 2.2 to 2.3 actually was today, which is the lecture I missed. So I guess I wanna cover this today as well. But firstly, I wanna do some linear stuff before moving on. I mean, in a way, I'm kind of unsatisfied with my understanding. I don't feel like I have a good understanding here. I'm not satisfied at all. So I want to do these problems though. Yeah. Where's my pen? Okay, let's do 3 for now. Yeah, I'm feeling kind of shaky. My foundation isn't really. I don't really have. I don't feel confident. So that's why I want to do these questions before moving on. I mean, even though I've attended the lectures and stuff like that, and I've done a couple of these questions already, but I still feel kind of that I don't really understand it that well. So is there a solution to the interval problem in a neighborhood of T0? Can there be more than one solution? Okay, interesting. So we want to firstly check if the function ftx is C1 in a neighborhood around 0, and let me think for a moment. Right, so we just it sure is C1. Yeah, so it's obvious since both partial derivatives, they're easy to compute, and they're just composition of elementary functions, which means that the function is continuous, and it's actually continuous on the whole real line, so it's certainly continuous on near 0. So yeah. You know, today on stats, I had like a lab, and I have to say, I understood very little, so I also want to spend a lot of time on that. I don't know what's up, but stats is like super difficult for me. But anywho, I'll talk more about that later. I just that popped into my mind. So yeah, I wanna see something. I wanna check. Let me think for a moment. Right, so I'm wondering, like, the definition of C1, like in the back of my mind, I automatically think that both partials need to be continuous. But then again, I'm thinking if both partials are continuous and exist, does that mean that the total derivative also is continuous? I think the answer is yes, and I don't think it's so hard to show. Stats is fantastic. It is interesting. It's like a totally different world. They have concept of continuity and like many similar things that we have in analysis, but it's just different. It's similar to like algebra. You're just in a different environment, really. Put videos solving G mathematics tough questions. You'll get a lot of views. I don't doubt that for a second. But do I want to do it? Maybe. Maybe I'll do some. But currently I don't feel like I have time. actually. But anyway, let's just do this real quick. Continuous. And the total derivative in this case is just the gradient. But let me just do this more generally. So f1 x, is this good notation? I don't know. f2 x, okay, let's just consider the matrix. F1 dfx. Yeah. No. Let's consider this. How do I? So we have f from Rn to Rm. I want to show that the matrix A is continuous. So if it's continuous between any points, blah blah blah. So we need to evaluate if I guess this is the total derivative. I'm not really sure. I think you usually write df. Yeah. So we get df of x, df of y, and we need to estimate it. So each component we need to estimate, and for each component, yeah, we can choose it to be arbitrarily large, small, and right. So if we, for example, use the operator norm for matrices, we should be fine, since yeah, this works. What is that? Someone was like coughing like crazy. Okay. I think I'm not exactly sure how it's written, but it's like this. The operator norm is bounded by all the components of a matrix, so we're fine. And we know that all matrices or our norms are equivalent. So if we show it for one norm, we know it works for all norms. Yeah. Blah blah blah. I want to ask ChatGPT just so my argument is good. If we know that all partials of a function is continuous, does that imply that the total derivative is also continuous? Blah 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 blah. Yeah, I remember this theorem. Yes. Yes, I remember this theorem. So it needs to be in a neighborhood, right? Where does my argument go wrong then? Huh. Alright, I think where I go wrong is the existence of the total derivative. I mean, I just pose that the Jacobian is the total one, but maybe the posed derivative or the total derivative doesn't fulfill this property. Yeah, I need to write this down since it's not. Yeah, let me write this down. Yeah, let's do that. A bit of a like parentheses or a tangent, but yeah. And f is, yeah, from Rn to Rm. And if this has limit 0, or if the limit exists, right, then we're good. Or rather, if the limit is 0. Indeed, okay. Let's see. Let's see here. I think this is like the little o notation, you can write this like this. Maybe. Actually, I've forgotten a lot about this. I've forgotten so much. What is the little o notation? Little o notation. Notation. Like if a function f is little o of g, it means that g grows significantly faster than f as x approaches a certain limit, which it can be mathematically expressed as I see. So it's 0 though. So you would write rather that is little o of h. Yes. Let me just check it is correct, and then let's move on. Yeah. Exactly. H goes to 0 instead of infinity. Well, it's supposed to go to 0. At least, I mean, in this I guess from Wikipedia and fandom they say that it goes to infinity, but in this case, I guess I just define it to be to go to 0 instead. I don't think it's that big of a deal. So yeah, but otherwise, I think it's fine. Alright. Let's move on. I'll just leave this. Okay, so by the theorem, we know it's certainly Lipschitz around 0. In the neighborhood of t is equal to 0, can there be more than one solution? I mean, in this case, there can't. I guess that's the answer, no? Okay, I think now we can move on. Okay. Should I spend time on lemma 2? Oh freak. This one is flipped. I guess I'll just I'll do this. Let's rotate counterclockwise. Okay, let n by n matrix be continuous function of t in the open interval I, then the solutions of the linear homogeneous system 9 constitute a linear space V of dimension n. All right. Oh, I remember this proof. So we find a bijective mapping between Rn and the vector space. Okay. Wait, let me try to so we have theorem 4. Okay, we found a bijective mapping where x0 is the initial value and the function in our vector space, where x of t is the corresponding unique function solution to the initial value problem. By the lemma, some elements x1 to k are linearly independent if and only if their reverse images in Rn by the mapping 10 have this property. Yeah, that makes sense. From this we conclude that the dimension of V is the same as the dimension of Rn. it got cooked today. All right. Let's try to replicate this. So we have a function x_a of t. So this is our initial variable problem with x of t naught is equal to x naught, and we want to show that right. So this has order. Yeah. So this is an nth order linear. So we'll say this is nth order ODE, and which imply that you know, x, each of the x's is, you know, in Rn for some n. And let me just close this. Maybe I'll make this a bit bigger. Oh, you can't even see what I'm doing. No. Okay, I'll move it down here so everyone can see. Pure math major, yeah. Yeah. Yep. Okay, so right, so we have nth order ODE, linear ODE, and we write it as a matrix. So yeah, we know it's continuous, so we assume ATX continuous near T naught, right? And therefore it is Lipschitz, which we proved before in the previous stream. We did do that. I forgot which one though. So it's Lipschitz near T naught x naught. I think that was what we did. Yeah, near this neighborhood, or rather near T naught neighborhood. Because we're just Lipschitz with respect to x, so it can't be Lipschitz near. I think so. Yeah, let's not look. Let's just. So this implies that we have a unique solution. There exist unique solutions, which we call just I guess x1 of t up to xn, or wait, what am I talking about? No. No, I guess it would be true. I get. Wait, this feels so weird. So we define mapping. Rn here. So there's a unique solution of the system with initial value. So for each initial, so it takes an initial value and outputs a, oh yeah, I guess that makes, yeah, obviously. You know, I made a mistake here of writing that there exist n solutions, but there is only one. Unique, it's a unique solution. Exactly. So there exists a unique solution, and the dimension is just the solutions that are linear independent. So yeah, so so this is just stating that we can have, for each initial value x naught, we can find a unique solution, and suppose we have, I guess here, yeah, if we have k elements in V that are linear independent, which is if and only if we have that the initial values x1 up to xk are also linearly independent, and we know that the dimension of Rn is n, so therefore the dimension of V is n as well. How do you actually learn new math concepts like theorems and stuff and their application? Is this a tutorial type stream or just learning for uni work? This is just a chill stream where I just learn and just talk about math, and hopefully we have some discussions maybe. Gosh, I love this thumbnail. It's so good. It's the best thumbnail I've ever made. Can I have this on Twitch as well? It's so good. I can't have a thumbnail on Twitch. Bruh. Okay, well, this makes sense. But it's still weird. The day I actually understand this book, I don't even know how to end this sentence, but it will take some time. It will take some time. I think I need to do proofs. I haven't done a lot of proofs in this book. I just need to force myself to actually do them, because usually I gain so much understanding when I'm actually doing the proofs. I gain so much understanding because you have to think about everything. I mean, you can't be sloppy at all. Anywho, remark for the linear system 9, you may of course also allow solutions x of t with values in Cn. This is often useful. Let me just think for a moment. Okay, what does this even mean? So this means that to actually solve an ODE of order n, we need to have n initial values. Yeah, just to make sense of this. So it shows that you need to have n initial values of an nth order linear equation system, which makes sense, since to solve generally a second order one, you need 2 initial values. I think. Why do not use copy pen to solve questions? I'm not sure what you mean by copy pen. solved 100 definite integration. My brain was dead. You're a lot better than me. I have not done my definite integral homework. Like, I've not spent that much time on it. Well, hopefully you feel confident. I would say I barely get by with my integration skills. Okay, you may of course allow these solutions, this is useful, we will do this chapter 2, and if A of t contains complex elements, it is necessary. Theorem 4 is unchanged in this case, but the solution set now constitutes a complex n-dimensional linear space. Let me think. Yes, okay. With values in CN. Right, so this will be a vector space V, right? You may bring this result back to the previous one by considering as a real system with 2n equations. The solution set of linear homogeneous differential equations of order n with continuous coefficients in an interval is an n-dimensional linear space. Yeah, so this is a corollary. Okay. The matrix with x1 of t, xn of t as columns is called fundamental matrix of the system. From the lemma above, it follows that for all t and I, the columns in f of t are linearly independent. Of course. Making f of t an invertible matrix. Yeah. Right. So it would have rank n, and that's equivalent to having it invertible. Is every column of f of t solves 9. We have that f prime of t is equal to a of t times f of t. By the way, we were solving for linear homogeneous equations for new people that are joining. Wait, does this make sense? The derivative of matrix is component-wise derivative. So the derivative is x1. So this would be x1. Oh, let's do this. x1 prime, x2 prime, xn prime, right? And these are solutions to the homogeneous equation. So we know that this can be written as A of t times x1 A of t x n, and this is let's just think for a moment. Am I convinced? Am I convinced? So it's let's just do A11, A2, A1, 2. Okay, it was a long time I did linear algebra, so I need to spend my time on this. Ay. Should I study maths to be able to solve complex problems like this? I mean, I don't think any engineer students are doing this. I mean, yeah. I mean, if you're doing physics, I'm studying engineering, so it's mostly physics, but I kind of want to learn more maths too. I mean, it depends on your university. If like, if you can take extra courses, you can take some extra math courses. But if you're doing math, or if you're doing, you say you're doing engineering, so most likely you won't do this. But I mean, most likely you'll stop after linear algebra and several variables, or calculus 3 or something. But maybe you can take extra courses, and I think the same is with physics. If you're doing a bachelor's in physics, you'll probably start after several variable calculus or calculus 3 and linear algebra. At least that's how it is in the physics program here in Lund. But I know a lot of physics people that do take extra courses. This one is an example. I know at least one physics student who's taking this is also doing physics. So yeah. Okay, so it's this times this, and let me for the yeah, I'm convinced. That makes sense. So it's just matrix multiplication, and you're fine. Okay. The matter courses are on things I have already learned, so I want to study more. Yeah, definitely talk with your like student counselor or whatever. I don't know the exact name in English, but if you can coordinate something, because I've been talking to them like crazy. And hopefully they're happy to help. I mean, usually they are. Okay, I want to move on. I don't have that much time. Okay, so we have the fundamental blah blah blah. Conversely, an invertible matrix with this property is a fundamental matrix. An arbitrary solution of the homogeneous system can be written as a linear combination of the basis vectors. If we introduce the column matrix C with elements C1 up to Cn, this linear combination can in matrix form be written. Thus the general solution of the homogeneous system is this. Yeah. Yeah. So these are the columns xi and of the fundamental matrix. Oh, yes, of course. I was thinking, why isn't there a particular solution? But we're just doing homogeneous ones. So this is, in the case of homogeneous ones, this is the whole solution. Okay. Using the fundamental matrix, we can give a formula for the solutions of the inhomogeneous. So okay, now we're getting into the stuff that I kind of didn't understand. So now we're working on equations xa of t, x plus b of t. Indeed. Okay, theorem 5. Okay, we have that fundamental. You know, I think if we just differentiate both sides and use the fundamental theorem of calculus, we should be fine. This would be equal to f t inverse b of t, and this is the identity, and this is this. Yeah, no, wait. No. Let's redo that. We need to use the chain rule. Yeah, so this prime is equal to hello, Charlotte, Eva. How am I? I'm doing pretty well. Hopefully things are good with you. Okay. Yeah. I think this is really short. Let me just look. Gosh, can you just do the product rule? Okay, let's just do this. I mean, I'm not totally convinced, but how did they prove it? Actually, they did it really shortly. G denote the integral. Okay, so just denote it like this. Okay. Well, I think it's the same. I guess it's kind of smart just denoting it G. You add f of t, and then you get f of t inverse, b of t. This becomes a of t x f of t. It's called g of t plus b of t. This needs to be x. X is G is F times G. How much do I study every day? I mean, I try to at least do a couple hours. I'm really enjoying these streams nowadays, or like these math streams. So maybe I'm doing a bit more studying than usual, but yeah. Glad to hear that I am doing well. Nice. How's your day going so far? It's going good. It's going good. It's going very good. Thanks for asking, Charlotte. I mean, to be fair, the only studying, like real studying, I'm usually doing live. So what you're seeing is basically all that I study. But today I did do a little preparation for the exercise class and stuff. So yeah. I need to convince myself. Like this. So we know that f of t is equal, or f prime is equal to f yeah, so we also had, did we have, no? Okay. Ew. Okay, we have an integral form for normal ODEs, or like initial value problems. Is this just the same but written? Okay, so this is a matrix times a vector, so we get a vector. And the inverse is where are you from, if you don't mind me asking? I'm from Sweden. Yeah. Currently in Skåne, in like the most southern part of Sweden. By the way, I'm also live on YouTube, Charlotte, so feel free to join there as well. The Twitch chat is kind of non-existent, but yeah. Man, I'm not convinced. How is this true? Wait, I'm dumb. I'm dumb. What am I doing? What am I doing? Oh my gosh, I'm okay, if let's just forget the past 10 minutes. I don't know what I was thinking there. Okay, obviously it just takes just clarifying notation. It's not. I thought this was something that was obvious, but this is what we're proving. Okay. Yeah. Wait. Now I'm confused again. How can we assume that this is x though? I guess this is where my confusion started. Is a solution for the inhomogeneous. Oh, yeah. Okay. Well, yes. Right. So we're trying to find the solution, and this becomes right. Okay. I guess I kind of misread the theorem. I thought we were gonna prove this type of like that x of t is equal to this, but no, we're proving that this is a solution to the inhomogeneous equation. Okay, that makes sense. Right, and we need to also check the okay. I mean, mistakes are good. You get understanding. So mistakes are good. Misunderstanding is good. Right. So let's check. So if x is t naught, yes, we get 0, since yeah, this whole integral will be 0, and yeah, matrix multiplication with 0 is just 0. And this is also a matrix, by the way. So it's, or no, it's actually not a matrix. Multiplying, yeah, this is a vector, not a matrix. Sorry, yeah. So matrix or vector times matrix is a vector. So yeah. Cool beans. Okay, general solution. So this is actually okay. Yes. So general solution of the inhomogeneous system can be written as that. Is it? Is it now? The general solution can be written for a linear system. The general solution of the inhomogeneous system can be written as a sum of certain particular solutions, and the general solution of the corresponding homogeneous equation system. For a linear system, the general solution of the inhomogeneous system can be written as the sum of certain solutions, and the general solution corresponding to homogeneous equation. I mean, fine, but have we even proved this? Yeah, so this is the particular solution, and this is the homogeneous solution. Maybe they proved it before, but I don't know. I mean, yeah, well, what is the proof of this? Do you guys know? Is it even written? I mean, sure, checking that the sum is a solution is certainly not something difficult, but how do you know that these are all the solutions? Right. Do I want a question? I'm not sure. It depends on the question, if it's relevant or not. Someone asked, I forgot, maybe he's in the chat. I think it was, I forgot the name. To prove like differentiability of the Thomas function or something. Which is, I don't know, which I skipped basically. But maybe I'll do it another time, I don't know. Relevant to math? Yeah, sure. I'm not gonna promise that I'll answer it though. Or if I even can answer it. Okay. Remark. In the case of n is equal to 1, the corollary is well known. See Formula 5 in chapter 0, page 4. Linear equations of order n. For simplicity of notation, put n is equal to 3 and consider the equation with variable coefficients. L of TD y equal G of t. So L T lambda is equal to lambda 3 A2 of t lambda 2 plus A1 of lambda. This derivative. We have put leading coefficients equal to 1. This equation is equivalent to a system where this is this and this is that, and where x1 is y, x2 is y prime, and x3 is y double prime. All solutions of 14 thus have the form yeah, indeed, where y of t solves 13. If we in particular have a homogeneous system, g of t 0, we conclude that every basis x1, x2, x3 of solutions to 14 via 15 leads to a basis y1, y2, y3 of solutions to 13. Solution 14 via 15 is to a basis, and conversely. Let F be a fundamental matrix of the homogeneous system which corresponds to 14. The fundamental matrix is of the form denoting the rows R1 respectively. They satisfy that R2 is R1 prime and R3 is R1 double prime. We use theorem 5 to construct a solution of the inhomogeneous system 14. let K3 be the last column in f of t inverse. Then assign is a column matrix. X is of the form 14, and the uppermost row thus constitutes a solution y of t. Okay, let's write this down. How many 5-digit patterns are possible such that the first digit is in 0 and the last digit is always 9? This can't be repeated. All right. Sorry about that. Let's see if I can kind of mess this up. There we go. All right. 8 times 8 times 7 times 6. I don't know if I agree with that. Well, isn't it 9 squared times 10 to the power 3? Oh, the last digit is always 9. Oh. Well, then it's... Isn't it just 9 times 3 to the power 3? Or 9 times 10 to the power 3? Anyway, blah, 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 blah. Let's see here. Okay, yeah. Where's my pen? Okay, there we go. So we have this. I'm actually not sure why there's a D there. L of T lambda 3 plus A2 of T. Right. So this is the like characteristic equation, right? So 3 this with leading coefficient 1. So I need to show that, yeah. Not gonna lie, I've kind of forgot how to solve second order equations. I mean, you find the characteristic polynomial and you solve it and you get 2 solutions, and then there are some other formulas there. So I guess what we want to show is the equation equivalent to the system digits can't be repeated, so there are more possible. I mean, if it right, but okay. Well, I assume that it could be repeated, but in that case, it would be correct, I guess. Yeah, I agree. I agree then. But when doing passcodes, you can repeat. Digits can't be repeated. I mean, I was thinking about like a lock, like a safe, like where we have numbers like. Oh, whatever. Oh, I see. Okay. Where y of t solves 13, we in particular have a homogeneous system. Oh, there's a y there. Y times. Ah, I see. Okay. So this is like a differential operator. I guess you could view it as that. Which book do you use for ODE? It's linked in the description, so you can see it there. At least, yeah, if you're watching in YouTube. On Twitch, I don't know. I don't think so. Maybe is there even a description on Twitch you can do? No, there's not even a description. Maybe I'm just such a noob. It doesn't seem like there is a description. Or I guess the title could be, but no. Also, let's do a sub goal or like a super chat goal. If we can do one super chat in 2 hours, I'll do what? Give me some suggestions on what I will do. For super chat, if I make the goal. Before I did 100 push-ups, and I guess that's the only time I've done it. So before I did 100 push-ups, should I do 100 push-ups again, or should I do 200 push-ups? Granted, I think 100 push-ups is enough. I did also do chest at the gym, so I guess I'm also a bit fatigued there. But I'm not sure what to do. Yeah, feel free to write suggestions. Maybe I'll take like a GEE question if someone has a good one. Probably I'll embarrass myself because I have no idea how to, like, I don't feel confident in it. But maybe I'll open a GGE or GEE exam and do something there. Maybe solve like the first question or something. If someone has any suggestions, I'll do it. If I reach the sub goal, that is, or the super chat goal. Yeah. Okay. I'm not sure if I really understand this. Right, so I guess we name x1 to be y, x2 to be y prime. Where y of t solves 13. Right, so y of t solves 13, and we say that all solutions to this is of the form of yt, since I guess we can write this as alright, so if we have if we in particular have a homogeneous system, we conclude that every basis x1, x2, x3 of solutions, these two bases rows, okay. Okay, I guess that's fine. Use theorem 5 to construct a solution of the inhomogeneous system 14. Right, so we know that the solution, or the particular solution, can be written like this. So we have this inverse. So K3 is the last column in this one. Right, so this is equal to K3 tau beta tau. So let's see, okay. Right. I mean, we have 0 on the first. This would be right. So this would be. Wait, is this a matrix, or is it a vector or not? Or we have G here. Okay, does that make sense? And what is G? Oh, G is the one here. So, oh yes, of course. So this would be just the last matrix, or yeah, it's the last column of the inverse, and which semester are you? I'm in my second or my third semester, I guess, of my So second year, so the first semester of my second year, or the third semester. Hello, it's Ivo. Welcome. Okay. Yeah, so I think I'm gonna take a little bit of a break. We've gone for 2 hours now, so I think it's appropriate. I'll continue for maybe I'll continue for 3 hours more. That's how long the stream will be. So I'm kind of unsatisfied how far I've gone, to be honest. I mean, if I can finish up this, it's kind of a lot. It would be nice to do some of the questions as well, but approximate solutions I'll skip. This one I'll also skip, I think. But if I can finish up chapter 1.2, that would be nice. And then if I can go on to chapter 2, that would be nice. Okay, so yeah, I'll head out for maybe 20 minutes or something. I'll grab something to eat since I'm quite hungry, and then I'll just continue on. So yeah, during this time, I guess I'll set a super check goal, and I don't know what I'll do. G questions, problems. Oh no, wait. Wait, let me turn off the goal. I'll do all colors, and I'll do towers. Alrighty, what's my major? I'm majoring in mathematics. Alright, I'll be back in like 20 minutes. Alright, maybe I'll put a, I think I had a lunch break. Yeah, dinner break. All right, I am back. Okay. All right. Let's continue. So where were we? We were in the inhomogeneous linear initial value problem. So yes. All right, yeah, we had this simplification of K3 times gy or g tau, and I instantly agree, since we know, or do I? We know that B is equal to 0, 0, G. So matrix multiplication would be, yeah, so only the G will survive, and in the second one the G will over survive, so we'll just have G times whatever this last one is, so it makes sense. I feel kind of refreshed now after also taking a break, which is always nice. Okay. Here XOT is on the form. Okay. Yeah. So by that theorem we get this. Well, rather, what is oh no, here we are. Okay. Yeah, so this is equal to f of t 0 f inverse tau, and then we have k. No. Here we only have k3 of tau, g of tau. Okay. And yeah. Here x of t is on the form 15. Right, true. And the uppermost row thus constitutes a solution y of t. Yeah, I guess. So this one constitutes a solution. Wait, let me see. X of t. A solution of the inhomogeneous system. Let K3 be the last column if f of t inverse. Okay, yeah, true. Okay, so we have so one solution would be the first row of the fundamental solution, like this. I guess so. Oh, I'm blocking. Okay. Yeah, so the row 1 is this, the y1, y2, y3 of the F matrix, So if we multiply that by the row or by the column matrix, which is this one inside here, we get a number, and this number would be the yeah, well, I'm not sure if I'm fully convinced. This depends on t, so we can just put it inside the thing. Okay, that was really messily written. And the condition x t naught is equal to implies that y t naught is equal to y prime t naught is equal to 0. Since R1 of t is a row matrix and K3 is a column matrix, their product is a real number, thus we put E t tau is equal to R1 K3, where this depends on t and this depends on tau. Okay, well, that's so we're now only looking at, okay, yeah, so we can only look at the first component of x of t. Right, so note we have that x of t is equal to y of t, y prime of t, and y double prime of t. Yeah, so if you just look at the first row, we can substitute the fundamental solution by row 1, which I will allow. Yeah, I'll allow that. Okay, we're just looking at this one. The condition x of t 0 implies that right. Since R1 of t is a row matrix and K3 is a column matrix, our product is a real number. Yeah, okay. Yt is a solution of 13. E is a real valid function of 2 variables. I guess. We now characterize E in another way. So we have denote by E of t the uniquely determined solution U of t with an initializer problem U of tau to 1, and then Y of t is a solution of the problem TD G of t Y of t naught 0 . Initial value problem. If tau is equal to u prime of tau, okay, I'm just gonna try to let ChatGPT explain because I'm not really sure what is going on here. I mean, first of all, L of TD is a differential operator. What is the difference between, or I guess in this case, lambda? Okay. Right, so L of TD is just the order D derivative. So, okay. So when we write L of U, it's equal to the nth order derivative of T plus an minus 1 of T, and then the n minus 1 order derivative. I guess that's how it's interpreted. U prime of T plus 8 naught of T. No, or wait, yeah, it should be first word, and then this should be U, right? Maybe because, or should it? So we're saying that this should be 0. Okay. Let me just ask, what does L of T D U mean? Yes. Okay. I'm not sure how much we'll do of this, since it is getting quite late. I have 2 hours left. I've spent 3 hours on this. So I should probably move on, unfortunately, and do some rather, I would like to do some Fourier stuff before moving on to statistics. I want to do this seminar, or like the seminar questions. Right. Short version is the compact operator notation. D denotes differentiate, is a linear differential operator, blah blah blah. LTDU means apply that operator to the function U. Yes, yes, yes. Oh yes, oh yes, oh yes. First order linear system, your context. Nth order scalar ODE. Yeah, so when k is 0, what would that be? D of 0, is that just 1 or is that U? I mean, initial value problem. What? Bro, this notation. Bruh. Let me copy this here. Why is tau used here? Maybe it doesn't matter. But if u of t is the solution to the initial value problem where u of tau is always 0, I'll just explain this more thoroughly. I am having a hard time understanding how u of t. I mean, I guess we can have a solution, but wouldn't the solution wouldn't the solution only be 0? In this case, I mean, u of tau up to the n minus 2's derivative is always 0. But the n minus 1th is 1. So here you would have 0. So you would have, here we have n like initial values, right? Or I guess it wouldn't be initial value really. Since, no, it wouldn't be initial value. Or would it? Like, what is tau? Is tau just a point, or? L of t du of tau is equal to u prime tau dot u is 0 comma u n minus 1. I mean, what is the definition of an initial value problem? I mean, you have some fixed points, like you have some fixed t that gives some fixed output. In this case, is tau fixed? Question mark? How is this an initial value problem? Don't be variables. Okay, well, I guess this encodes differential equation, and this encodes the initial value stuff. Mayhaps. Let me open linear analysis. And check the problems. Yeah. Cool. So we're in week, no, not week 3. Convolutions, week 4, chapter 2.4, and then we have seminar as well. So we need to do the question 3.17 to 3.24. Did I attend this lecture? I think I did attend, yeah. Probably have some lecture notes. In the meantime, I was waiting for like AI to answer. Whoa. Okay, maybe it was another textbook. Probably another one. Or maybe I lost them. Oh, they're probably here. I'm very, very disorganized. I noticed. Here we are. Oh, this was ODE, I see. Yes, okay, well this one wasn't really that difficult, I would say. Yeah, that one wasn't that tough. Alright, and then the other one were stats. I think actually I wrote it here. Yes, uniqueness of Laplace transform. Yes. And yeah, okay. Okay, this is actually not really that difficult. I say that now, but probably it's very difficult. But I guess it's not as difficult as this. I would say the ODE stuff. Notation hides a simple idea. You have an nth order ODE, linear ODE. Right, so this is just notation for this. But okay, so this is yes, it is a homogeneous thing. There isn't a constant term. Each fixed tau, for each fixed tau, think of chosen at start time, we consider the initial value problem. For each fixed tau. By the standard existence uniqueness theorem for linear ODEs with continuous coefficients, this is a legitimate initial value problem. The initial time is t is tau, and it has a unique solution, u of t, on an interval around tau. We name that solution. So tau is a fixed point. Yes. So this is a specific kind of initial value problem where we have this initial value problem, and these are n in total, which I think we need to have. Let me think. Yes. Yes, by the theorem of that the vector space of solutions to the ODE is always of the same order, or is the same number as the order of the ODE. We need to have, and we know that the dimension of the solution space is the same as the dimension of the the dimension of the variables, or however you say. So I think this means that we need to have an initial values at all times. Okay. And it has a unique solution. We name that solution. Okay, yeah. So this is a legitimate initial value problem, and it has a unique solution y of t on an interval around tau. We name that solution e of t tau, because we can choose tau anywhere in the interval interest. E becomes a two-variable function. Is the unique solution of star. Acts on t variable only. Tau is just a parameter indicating where the initial data are imposed. Solving star tau fixed, after we've done that for every tau, we have the whole kernel. This E is the Cauchy kernel of the homogeneous equation normalized by those initial conditions. They are so that we get exactly the inhomogeneous solution with zero initial data. Okay. Wait. Oh yes, of course, yeah. So okay, so if it's inhomogeneous, we have the g of t here. They are chosen so that for y of t is this, we get exactly inhomogeneous solution with zero initial data. Sketch of the calculation, differentiate under the integral. Yes, okay. I have a mental model. Think t tau as the system's impulse response starting at time t. Set all derivatives to 0 except the highest order derivative. Then let the homogeneous dynamics evolve. The driven solution is a weighted superposition of these impulse responses with weights g of tau. If you rewrite the scalar nth order ODE as a first order system with x and let psi or phi be a fundamentals matrix with phi of tau being the index. Oh lord. Okay, cool. Let's see here. Okay, so this is just a way of writing the homogeneous nth order ODE. Denoted by E T tau, the uniquely determined solution UT of the initial value problem. Then we have that this construction is a solution to the inhomogeneous initial value problem, which we can denote by that. And in this case, okay. Wait, didn't we already have a solution to the inhomogeneous equation? The general solution of the inhomogeneous system 11 can be written like that. Okay, let's see. I mean, we know that the solution is this for any like this. This is the general. Oh, let me move this up. General solution to inhomogeneous initial value problem. Okay. And in the coming part, we are wait a minute. This is the fundamental solution. So we have x1, x2, xn, and we are integrating like this. Okay. Okay, so what is the difference between these two theorems, essentially? I'm just trying to understand that. Because in this corollary, we say that the general solution of inhomogeneous system is this. But I guess we don't know the column matrix. We have, okay, so for this one, wait, let me think. I see, so and we're given an initial value. Using fundamental matrix, we can give a form of the solution of the Marsh system. Let me look here. This is assume I mean, it's always good to remember that this means that we have that x, yeah, so we have that x of t naught is equal to x0, x prime t naught is equal to 0, up until n minus 1 of t naught is equal to x naught. And this is equal to this. That's a vector. Okay, let's see. What is the difference between corollary 2? Here we're saying are we saying anything extra here on 6? Yeah, I think that's a pretty good question, honestly. I can't really answer it. Okay, I think I'm just gonna call that done. Like done with ODE 1. And maybe I'll just I'll just make this red for the things that I'm done with. And Oh, snap. Oh, that's annoying. I'll go on to Fourier. Copy. Oh, we can duplicate. Fantastic. Green. Oh, okay, nice. Same idea viewed in different angles. What theorem says? 6 says Cauchy Green's functions view. So with nth order scalar linear ODE, for each fixed tau, solve the homogeneous initial problem. Call that solution ET. This is called Cauchy kernel. Then the unique solution with initial data at T0 is with 0 initial data is T0. At T0 is. For the general initial data, you just add the homogeneous part. Or okay, our homogeneous solution chosen to match that. Okay. Build the solution using a kernel and explains why those special initial conditions make the integral produce g of t after applying L of td. It's the impulse response viewpoint. Matrix version of the first order using a fundamental matrix is a more general structural statement. It constructs a Cauchy kernel and shows the integral representation. Okay, cool. Cool. Let's move on. What is this? Oh, what? Wait, is my goal 10 super? Okay, well, this is crazy. That was not the idea. No, I did not want to do 10 super chats. What the heck? No. It's only one super chat. Yeah, feel free. So if we reach this, like the donation goal, I'll try to solve at least some problems of G, like a G problem. Or, yeah. Yeah. Okay. I guess this is just the thing here. Okay, cool. Let's open the book. The book. Let's open the book. Downloads. Fourier analysis, Fourier plot. There you go. Perfect. Okay, so we have section 3.4, but I'll rather do the problems 3.17, 3.24. 3.17. Here we go. Let's just move the work here. Fourier. Okay, so 3.17. Invert the following Laplace transforms. Okay, so s plus 1. Let's see. Interesting. Okay, well, I know that the Laplace transform of 1 is 1 over s, and I know Laplace transform of e to the x, or is it negative x, is 1 over s minus 1. I think. Let me check. Okay, I guess let's just try to compute it. So it's from 0 to infinity. Ex e negative st t. Wait, is this supposed to be t here? Yeah. So it's Let's. T equal to 0 infinity, or let's just do this. This will be a constant I mean, it will just be 1 minus st e, or divided by 1 minus s, and when so I guess this is the same as like this. Right, so it's minus this, which is the same as s minus 1. Right, so we get the same answer. Perfect. Perfect. chat seems kind of dead after I came back. What happened? What happened, everyone? Has everyone gone to bed? Am I actually gonna solve the G exam? I don't think so. Seems like everyone's sleeping now. I'm not sure. Is this just the solution to L of focusing? Noise. Yeah, I'm not really sure what the inverse here is. I mean, yeah, I guess I find yeah. I mean, you're working on your own, which is fair. But I mean, if the streams help, that's nice. What are the rules? There are some rules. Theorem. Right, we have that this is equal to S of F minus F0 this. You're much better in math than I am, so better don't expect something smart from my side. I mean, I think we had nice conversations at the start of the stream. But I guess everyone's focusing, that's fine. Let's see here. But yeah, what math are you doing? Cut splits? Are you in like high school or what? I don't think I've seen you on these lives. Or maybe I've just forgotten. Alright, so we have these rules. Can I? Man, honestly, what the heck? Why can't I solve this? I mean, maybe it should be easy. Maybe it's just this ET dt times 0 no ST dt. These are I guess we can merge them. Studying psychology in Germany, probably beginning stats master next semester. Oh, that's like, isn't that like a bit of a leap from psychology to statistics? All right. Well, good luck with that. Where in Germany are you studying? I was recently in Bochum, Germany, near Düsseldorf, and that was an interesting place. I was at the university in Bochum University. I have to say that university is a lot more high tech than the one here in Lund. Not gonna lie. Let's see. Is it? Oh, maybe it's just E. Just like 2T here. ESTT. Because or no. What am I doing? What am I doing? No, it's obviously not that. Actually, I'm not even sure what this is. Probably just ask AI, honestly. Psychology is basically stats. I also study computer science. So there's the math background, basically just completing the journey. Oh, okay. Oh, that's interesting. I didn't know, like, I never studied psychology, so I don't really know, but that's interesting. I mean, I guess if you're doing any kind of science, you're naturally doing statistics mostly, I would say. Like compiling data and stuff. Complete the square. What the frick? What is this? 2s3 is 2 plus 4s is 13. Laplace of this. This is equal to 2s plus 3 is 2 plus 4s plus 13. Oh, right. Right, so we complete the square. Plus 2. plus cos of t is t to t. Yes. I think we did partial. Negative sine t is 0 infinity plus sine t es t to t. This is this is t goes to infinity. This will go exponentially 0. This is 0 is 0, so it's just 0 now. This is 0 plus then we do 0 infinity sine. No. So this is yeah, so this is the primitive of this. Yeah. So we're just doing partial integration here. And then we're doing it twice. I think this will work though. I'm not really sure though. Oh, well, maybe it will work. So then we have cos of t e s t s 0 and minus minus 0 cos of t e negative s. Right, so it's plus s squared t, and this is, I think it's just infinity. This goes to 0. 0, it should be 1 over s maybe. 0, 1, 0, 1. Okay. Plus this, which is I s squared. This is I. So we get I minus 1 minus 1 over s squared is equal to s. If only I is equal to 1 minus s squared. Like this, and get s squared, s squared, s Yes, precisely. You have 2 e negative 2t cos 3t Laplace is equal to s plus 2 square plus 3 square. What? What's going to do denominator? The split up numerator to enable us to recognize transforms for cosines and sines. Alright, I'm gonna go to the bathroom real quick. Alright, cool. Will I do stats today? Probably not, actually. I don't think I'll have time. Because I noticed that I'm quite shit at this. At finding Laplace, inverse Laplaces. And it does, yeah. So I'm probably not gonna do that. So, okay, so this is the inverse Laplace of cosine. And okay, so oh, okay. Yeah. I see. Yeah. So the Laplace of cos bt is equal to s square minus b square, and the Laplace of sine at is equal to s plus b square. Then apply rule 2 to the result. Yeah. Well, wait, rule 2 is, oh, I see. EAT of f of t same as plus of f evaluated this s minus a. Wait, what are you working on in N18? How's it going? Have you done some Fourier stuff? I mean, you mentioned you did some measure theory, but yeah. I mean, finding Laplace functions. Have you done that? Just curious. Okay, let's see if I can find Laplace of. So apparently we have, yeah, 2 times. Okay, yeah, true. Okay, so we know Laplace is linear, right? Yeah, exactly. And oh, is it the damping rule? Damping. Yeah. And then we have T A minus A is equal to E A S. Currently doing research, find a cool way to tighten an upper bound in one of the proofs. Very thrilling stuff. Nice. How do you mean tighten an upper bound? Like write a better and shorter proof? I'm guessing so. Cool. So this is the delaying rule. Oh man, these rules. Wait, okay, so this one you use the linearity times e negative 2t equals of 3t. I think this is the same as yes, this is the same as Laplace of cos of 3t minus 2t, or no, minus 2. Oh, you can't even see what I'm doing. No, it should be plus here. Oh, I see. Wait. Yeah. Oh, okay. Wait, cos 3t is equal to this. Is Laplace of cos of 3t plus 2t. 2. It's my birthday. Should I study or take a break? I mean, do what's best for you, but happy birthday nonetheless. Maybe if you feel like it, take a break. Thought of a better way to perform the analysis of infinite sum. Improved it exponentially, which says more about how bad the previous bound was than how good this one is. Well, I mean, you can look at it in both ways, eh? When I took abstract big picture courses in Fourier analysis, I kind of remember Laplace or so, but don't count on me here. All right. Noise. I mean, it seems like a pain in the butt. Not gonna lie. Wait a minute. Oh yes, okay. I mean, I guess this is true. S plus 2. Just this, and then S plus 2 square, and then we have plus 3 square. Right, yeah. Right, and then this one we have negative 1, 3 s plus 2 plus 2. So this would be the plus of e, no, it's plus there, so it would be e negative 2t sine of 3t Is this a regular course in your curriculum, or are you taking it a semester early? This one I'm taking, I mean, to be fair, no, like all the obligatory courses or have already happened. Like in the first semester, you have to, like, all the courses you take are like obligatory. But now in the second semester, or in the third semester, you only have to take stats, and then all the other courses you can basically do whatever. I am taking one extra course, and I'll say that is ODE. It's yeah, and but most people take linear analysis. Some people who want to like do some more stats stuff. I know I have a friend who's doing it's like linear algebra, but like numerical linear algebra, and then he's doing some algebra course, abstract algebra, which is fine. So it kind of like there isn't really regular courses in the second and third year, other than stats. It's close. Oh, I see. So this should be there. Okay. Here we have obligatory classes all the way up to 5th semester. When does the semester end there? When do you sign up for the classes in the fall? I mean, this semester ends December, I'm pretty sure. And then after the winter's like holiday, or the Christmas holiday, then the spring starts, spring semester. But yeah, when they sign up for classes, I mean, it's usually during the summer, like mid-summer to end, like end of summer, like August. You usually sign up and then you get results, like if you got into the courses and stuff, which you should like automatically, if you're in the program, you should automatically get into the courses, but you still have to apply for the courses, even if you're a program. Yeah. Okay, I actually still don't really know how to solve this. This one for some reason. 17A. Plus 1. I mean, B I can solve. That one should be easy. This is just equal to or maybe it isn't easy. Or yeah, it should be easy. It's 3 times e to the t. Pretty sure. I know this is equal to 3 times of 3 t minus 1 is equal to 1 over s square. Yabba-dabba-doo. C1 over s plus 2 square. Is this the Laplace of e negative t? I think it's just negative t, right? Wait, let me think. I'm not sure. Negative t minus st, so it's just 1. Take out the negative t. So it's negative e 1 plus s 1 minus or 1 plus st this yeah. Well, is it like the double Laplace? No, I don't think so. Infinity. Yeah, so this goes to 0 plus 1 over 1 plus s times 1 s. Yeah. what is the inverse Laplace of SS plus 1. AI for the win. Man, it's getting late. Ew, we can do partial fraction. Oh, well, that helps. By the way, when can we do partial fraction? I don't think, we've used partial fractions, but what are exactly the bounds? I can't recall, and I don't think it's ever been proven. I have never proven partial fractions. I'm not sure if anyone here has done it. I remember it's just stated as being true or claimed. But maybe it's an easy proof. Or maybe not. These types of questions is just looking at the denominator and looking for patterns. I mean, with the Laplace, it is, yeah. Okay, my brain currently can't comprehend this. Can be done almost always. Yeah, but there are some situations where it doesn't work. But usually it does. True. But I haven't really dived into exactly when it works and when it doesn't. For another day. Let's do this first. I mean, I'm not sure. Is it when, like, the polynomial in the denominator is equal, has degree less than or greater than or equal to the numerator? I'm pretty sure. Here, what can we do here? I mean, let's try partial fraction. Can this be written as, I mean, I'll just do 1 over s a, or we have a square, so it's maybe I kind of forgot. Do we do ax plus b? Where we used it. Open the formulas if necessary. Usually you can identify what composition is with enough time. I mean, yeah, here you would do a let me just do it here. Okay, I'm not really sure with that one. I'll just move on. Well, this one should work. So here we have, I mean, a plus b is 0, a b plus ba is 1. This one is, or maybe you expand it. Is it? yeah, so it's always using partial fractions. I mean, here, since it's quadratic below, I'm pretty sure you do a plus b divided by s squared plus cx plus d. S minus 5 squared. I'm pretty sure. And yeah. Do you make formula sheets separately or like for revision? I've never done it, to be fair, but I mean, it's always good to review like all the important theorems and stuff. So, but formula sheets usually, I mean, you're not allowed. I mean, all the exams I've taken, you're not allowed a formula sheet, so it's not really useful in that sense. I know for my friend who's doing engineering, you can take your own sheets, like cheat sheets. But yeah, I'll just let me just copy this. Or maybe I'll just I think it's correct. I think it's correct. So we have that. Oh, frick. Oh, this will take forever, dude. Wait, we have X here. This should be an S. X plus D to the 3, then to the S2. We get A as 3 minus 10AS2 plus 25AS BS squared oh my days, these problems were crazy. It's just invert and invert and invert. Ay, ay, ay. Solve initial value problem, solve initial value problem. So 17 to 24. Yes. Yeah, very tedious, very tedious problems. I'll try to get done with a couple and then I'll probably end. Feeling kind of sleepy. Not in canonical form. Oh, I mean, it's equivalent, no? The denominator is a product repeated. Has redundant linear numerators. you can rewrite it into canonical form. Okay, well, okay. So we have that S3 times A plus C with F2 negative 10A plus B plus S negative 10B plus 25A. Wait, D squared. Oh. C squared plus D. Yeah. Plus 25B. Zero. All right. That's, I think correct. Yeah, maybe. So what do we get here? Oh, whatever. Whatever, dude. When is this problem set due? Well, I guess it's like seminar problems for tomorrow. But these are freaking tedious. Very, very tedious. I'll probably just skip the seminar, to be fair. I mean, usually I skip these seminars. They're really not that difficult, but just rather annoying. But still good to do. I mean, obviously they're good, you know. But here you complete the square. I think with 2 times 2, so it's S. I don't know, I find this very, very tedious. I mean, these kinds of problems. Just kind of depressing, not gonna lie. Right, so we get 5 square here. How convenient. And then we get, this is the Laplace of what in the world? Ah, I know. 1/25 of sine of, no, e to the negative t sine of 5t. Something like that. What do you mean seminar? How does the course work during the week? Yeah, so you usually have, like tomorrow I'll have a lecture, and it will be from like, I think this to this, and then I'll have a seminar. This is like the lecture, and then I'll have the seminar. And basically there's like a seminar leader or whatever you say that goes through specific problems. So tomorrow I'll have, yeah, the problems are stated here, like wait, did I fuck up? No, I'm looking at the wrong week. Okay, yeah, so 3.17 to 3.24. So that's usually have like a lecture and a seminar 2 times per week. But some courses are kind of different, like you have a lecture one day, a seminar one day, and a lecture one day, and a seminar one day. But yeah. Oh. But don't you usually have seminars in your courses and an 18? Okay, I'm done with these stupid questions. Stupido questions. Annoying. I hate computing stuff. It's the worst. I'm so bad at it as well. I'm so bad. But anywho. Yeah, so we have ax plus b. I mean, I guess practicing partial fraction decomposition is not a bad idea for me, at least. It's not. But I mean, it's not really. The rules are fairly okay. I mean, they're not really that complex to BH. Oh yeah. Okay, so there is axs plus ax plus bs plus b plus cs square is equal to 1, so we have yeah, so we have S plus C, S squared plus A plus B, S plus B. Okay, so B is equal to 1, A is equal to -1, C is equal to 0. Maybe this is correct. I mean, I guess you can always check. Wait, C is 0? No, it's supposed to be 1. We have the equivalence of TAs. Do quote-unquote practice lecture during the week. I think this is the same as the seminars over there, but you also have regular seminars, right? The courses and presentations. Yeah. Of TAs do practice lectures. Right, so yeah, so they go through practice like problems and stuff, but you have regular seminars. I mean, I'm not sure what you mean by regular seminar. This is all I know. I mean, seminars are usually you present problems on the board and you discuss with the teacher assistant that's having the seminar, and then you have the lectures where you just listen to the lecturer talk. That's usually the two main things. And for the introductory courses, you have more, like you have the exercise classes, like where I hold in for one variable and algebra vector geometry course. But yeah, usually just seminar. And I mean, I'm not really sure what you mean by regular seminar. Yeah. But I think seminars are usually like that, no? Maybe not. Anywho. This is equal to 1 over s squared minus 1 over s plus 1 over s plus 1. This is equal to Laplacian of t minus 1 plus e negative t. Do you all not have any classes online? Nope. I mean, yeah, these are all classes that are physical. Yeah. Oh man. B square s square plus b square. I'm not doing that. Goodbye. Invert the following Laplace transforms. Wait, this looks a bit weird. 1 plus es. Wait, what? Is there a Laplace transform that has e? The heck? Okay, it's 5 minutes until midnight. Yikes! I want to do one of these ODE problems because I haven't really done any of those, but they look kind of interesting. I mean, not really. But a little bit. to be fair, I should also probably look at the material to prepare a bit, but I don't know. Maybe I'll just skip that and do it during the lecture. I found that having the book open, like your course literature, during the lectures is actually kind of meta, honestly. It makes it easier to follow, I would say. Yeah, I've started doing that the past week, actually. Okay, so the idea is to take the Laplace on both sides. Laplace. So you get Laplace of this plus this. They get 2 times 1 over s minus 1. And then you get minus the derivative. I don't really know what's there. No, wait. I forgot the rules. So it's equal to S or f of t minus f of 0, like this, or rather I'll just do y minus y of 0 plus yeah. Right, so we get s y tilde. Yeah, so this is the derivative as well. And I guess you could do it again. S, then you get S prime of 0. This would be S of Laplace of t, I guess, or S. And then minus y 0 plus minus y prime of 0 is 2 minus 2 plus y thing 2s minus 1. Here I think seminars are either courses where the lectures are given by the students taking the course, or topic seminars where students present their thesis as part of the requirement of their degree. Oh, that's very interesting, actually. A lecture are given by the students taking the course. Wait, how does that work? Okay, well, that's interesting. Okay, well, I guess that's maybe higher level seminars. Also, good on you for being a TA in your 3rd semester. Hope it isn't too time consuming. I mean, it's not really that bad, but I find it kind of nice. Like, it's I learn a lot, and it is a fairly time consuming, but it's like worthwhile 100%. I really like want to get good at the foundations. Like today, the topic was like baby number theory. So what are how do we define divisors and stuff, and then division algorithm and Euclid's algorithm, and stuff like that. Bezout's lemma as well. And that was certainly not something I'm very familiar with. The university I'm in is mostly an analysis university, so the algebra classes are not really popular, and there doesn't really exist that many. So it's more difficult, and I kind of forgot a lot of the stuff. And to be fair, I don't even know if I ever actually read, for example, Euclid's algorithm proofs thoroughly. I had no recollection in my mind that I did that, so it was good that I did it now. But yeah, I recommend being at the AI. It's nice. Okay, so this is always also 2. We have s squared y tilde minus 2 minus 2, which is minus 2s minus 2 plus y tilde 2. I mean, and then it's just solving y tilde and finding the inverse Laplace, right? Which, I mean, s squared plus 1 y tilde minus 2s plus 1. Okie day. So this, you can't even see stuff. Two s minus 1 plus 2s plus 1 divided by s squared plus 1. So multiply by this, you get 2 plus 2s squared minus 1. Yeah, so we get this divided by s minus 1. S squared plus 1. You don't understand anything or do not do anything the entire seminar, and in the week you're presenting you do 10 plus hours of prep for a lecture. The rest won't really understand either. Well, I guess, well, yeah. I mean, you focus on yourself, I guess. But is it? I mean, that's so you get a topic you need to present, and then you try to, I guess, explain the topic. And I guess, I mean, I guess you're evaluated in the material you cover, not really if people understand it, which is fair enough. I guess it is what it is. Bro, finding the inverse of this, actually it's not really that difficult. No, it's not really that difficult. Or maybe it is. This S squared term is kind of annoying. But anyways, I'm done for today. It's midnight, or past midnight even. So yeah, today was a 5 hour and 5 minute stream. I'm pretty happy with how today went. Granted, I didn't really do any statistics. For analysis, I kind of didn't really finish that much. ODE took all my time, as always. I mean, yeah. The math police was looking for me, and luckily they didn't find me. But yeah. I mean, I didn't do anything really illegal today. I mean, some days I'm very sloppy, so I mean, then I gotta be on the lookout. Okay. Anyways, I'm not gonna talk anymore. I'm just speaking nonsense. The seminar has a general theme, and then every student/group gets a specific topic. The evaluation might as well be in orange. All right. Well, that's interesting. Anywho, tomorrow I'll do another similar stream to this one. I'll try to start at around the same time and do the same length, like 5 hours, something like that. So yeah, it was nice having everyone here. I'm really enjoying these math streams. I don't know if the same can be said to everyone else in the channel. Honestly, I don't think so. People mostly don't like this, but I do what I like, and stuff like that. I mean, it has been a long time since I've actually enjoyed making videos, not gonna lie. So I'll just stick to this to enjoy life. But I think I can make these streams better, and a lot better, so I guess stay tuned for that. And if you have suggestions for anything that I can do during the streams, feel free to message me on Discord or something like that. Or even better, just ping me on the Discord server. I'll probably most likely view it on the Discord server rather than if you message me. But anyways, yeah, I'll see you guys tomorrow. Okay, have a good